Hi. In today's lab, what I'd like to do is I'd like to talk a little bit about encryption and the different types of encryption, and I'd also like to go into some of the tools that I use to help me stay secure. So for this lab, what I'm going to be doing is I'm going to be opening up my Windows 7 machine, and I'm going to be doing all my work from there. So I'm just going to right click and do an Open Console. And to start with, what I want to do is I want to attach to a CD that I've got inside the Tools directory. Looks like I previously had one. And I'm going to connect to an ISO image on a data store. And I'm currently inside the Tools folder, so TISO images, ethical hacking, and then Tools. So I'm currently in the Tools folder, and I've got a tool here called GPG for Win. So I'm going to just attach this ISO, and I'm just going to open it. So it's my D drive. And I'm just going to drag this onto my desktop. So I'm going to go full screen here so that way we can get a good picture of what's going on. So what I want to do is I want to install some software that will enable me to do some PGP style transfer. Now PGP was a tool that was written back in the mid to late 90s, and basically a guy named Phil Zimmerman came up with a software package that allowed people to transfer data, email, text in a very secure way. So the name PGP was a complete understatement. It's really awesome protection. So what previously happened to him writing this software is two math guys got together, Diffie and Hellman, and they spent some time talking about how they could do a math equation where each one of them would have a part of the problem. No one would have the complete problem, and then they were able to derive numbers from this mathematical equation. So really the credit goes to Diffie and Hellman for creating the public key cryptography that we're using today. So Phil Zimmerman ended up writing out PGP, was a software package that he released, and at that time it was a freeware, and he released it on the World Wide Web. And he ended up getting in some legal issues. I think he ended up getting arrested for like a weapons embargo or something like that. Basically, what happened is he publicly released an encryption algorithm that was stronger than any government could end up cracking, which was a security concern because now people like you and I can communicate in a way that would prevent governments from knowing what we're talking about. So it was a huge release which opened up a whole conversation on how things should be done. So over the years, PGP matured and it's a full product, and it's now commercial, so it plugs into your email, and every facet of your life can be encrypted. What we're using is one of the GNU open source projects called GPG, and GPG is basically the same thing as PGP except for it's an open source version, and because it's an open standard they can talk to each other. So the way it works is it's a block style cipher, so that way we're going to take some data and we are going to encrypt it, and then it's going to be a little bit more CPU intensive, and it's going to take a little bit longer to encrypt and decrypt, but it gives us a very, very secure way of transferring data. So what I'm going to do is I'm just going to go ahead and install this. Okay, so I'm just going to go through and I'm just going to take the defaults here. Okay, so what I'm going to do is I'm just going to open it up. I see Cleopatra is here. That's going to be what we're going to use to um, handle our keys. So if I go to all programs, there is the GPG for win, and I'll see Cleopatra there as well. So when I open this up, what I'm going to need to do is I need to create a key pair. So I'm going to need to create a public key and a private key. So it's using that same public key cryptography that we use like when we purchase things online. It gives us the ability to give publicly a key out that people can see, and it'll also give us protection. So the very first thing I'm going to do is underneath the file there's a new certificate. So I'm going to click on File, New Certificate, and I can create a personal open key pair. I can create a personal key pair and a certificate request. So I think I'm just going to select right here the key pair created locally, so that way I can communicate to people in a secure fashion. So I need to give it some details. I need to give it my name, and my email address. Okay, so here's the downside with PGP style encryption. It's using trust. So whenever you're using trust, there's concerns there. So if I were going to maybe try to do some social engineering and do some hacking and get some information that maybe doesn't belong to me, what I could do is if I knew a certain vendor, Bob Smith, all right, and Bob Smith was dealing with a certain customer, some social engineering I could do is I could go to Gmail and I could create, bobsmith129@gmail.com, and I could create an email address. And then what I could do is I could come in here and use Bob Smith and use the bobsmith129@gmail.com, and I could create a certificate with bogus information. And then from the Gmail account, I could email this certificate to one of Bob's customers that I'm trying to steal and say, hey, for future communications, I do not want to use my work email address. I'd like to use Gmail, and I would appreciate if all of our communications is encrypted. Could you please use this certificate? That would be one way that you could use social engineering, and that's the downside. So there is something called the Circle of Trust where people will have like key signing parties. I know that it's a big deal like at DEF CON and other conventions where you have to show your ID and then they'll validate that you are who you say you are, but that's still something that's questionable. Okay, so I'm just going to continue on with the wizard here. I'm going to go next, and I'm going to create a key. So I need to give it a passphrase, so I'm just going to type in a passphrase that's secure. Okay, so I've got a passphrase. I'm going to say OK, and it wants me to re-enter it, so that way knowing that I've got it right. Okay, so it created our key pair and it gave us a fingerprint. At this point I could back it up. I'm just gonna say finish at this point. So I can see that I've got a key here. So I've got my certificates, trusted certificates, other certificates. So I'm underneath my certificates, and what I want to do is I want to right click on this and I want to do an export certificates, And I'm just going to put it right onto my desktop here. And I'm going to hit save. So it exported out what they're calling a certificate. If I open this up in Notepad and take a look at it, I can see what the certificate is it's a PGP public key. Okay, so we've got our own PGP public key. So this is one part of that mathematical equation. I can give this to anyone. I can post it on my website. I could post it out publicly. It doesn't matter. No one could crack my encryption with only having my public key. They don't have my private key. They only have my public key. So all I did was I went to my certificates, I right-clicked on it, and then I did an export certificate, and then that put this out onto my desktop. So I'm just going to rename this. I'm just going to call it my first name and my last initial. And I want to upload this to Blackboard. So this is something that I can publicly give out. So if I go to Blackboard, so I'm going to go to the college's website, and I'm going to go to my FETC. Then I'm just going to log in. And I'm going to go to the ethical hacking class. And then within the online course, in the discussion board, I've got a thread in here that's called Key Store. It's the very last one. It's the PGP Key Store. If you go into the PGP Key Store, this is where people will start to post their public keys. I'm going to create a new thread. And I'm just going to do Joe's public. Key. And what I'm going to do is I'm just going to browse to my computer, and I'm going to grab my public key here, and then I'm going to submit that. So what I'd like you to do is I'd like you to grab somebody else's key. So like for example Glenn's here. This is an example. I'm going to download Glenn's key. I'm just going to save it right to my desktop. And what I want to do is I want to import certificates, and if I go to my desktop I see the brown, and it said that it successfully imported Glenn into my system. So at this point what I can do is I can throw these away. These are just the public keys. If I right click on it, and let's just say I want to create a new text document, and I'm just going to call this thing cool stuff. Alright, so the cool stuff, I do not want anybody to see this top secret document. Okay, so I've got a top secret document that no one can know the contents of. So I'm just going to save this document. And at this point in time, what I want to do is I want to encrypt it, because right now it's plain text. Anybody can see that. If I were to post this on Blackboard, anyone could read it. But I only want Glenn to read it. So what I'm going to do is I'm just going to right click on it, and I'm going to go to my context menu where it says sign and encrypt. So if I go to the sign and encrypt, by default it is encrypted. So if I wanted to sign it, what a signature is basically it takes the contents and then it encrypts it, but it doesn't encrypt the contents, it just creates a signature, so that way someone can compare the signature with the original text. So if somebody were to modify the document, the signature would no longer work. Normally I don't use signatures, I just encrypt the data. So I'm just going to go next. And I need to decide who I want to be able to have read it. So I'm just going to grab Glenn here and add him in. And I'm going to encrypt this. And it's giving me a warning. It's saying you did not add your public key to the encryption. So after doing it, you will not be able to decrypt it because only people with the public key can decrypt it. And I'm going to say that's fine. Okay? So it successfully encrypted it. So at this point, I've got this cool stuff.text.gpg. So if I were to look at what was inside of there, this is what the encrypted stuff looks like. So it took the data and it encrypted it using one half of an algorithm, and I don't have the other half. So I've got the public key, so it encoded it to the public key, but since Glenn is the only one that has the private key at this point, I can't decode it. So what I'm going to do is I'm just going to go back over to Glenn's thread here, and I'm just going to reply, and I'm just going to attach the cool stuff that I encrypted. So at this point, I'm going to submit that. Now Glenn will be able to right click on the cool stuff.text.gpg and he'll be able to decrypt that message, but only Glenn will be able to do it. So I'm just going to go over to a different thread here, and I'm going to grab somebody else's data. And this is for a different class, and I'm just going to intercept someone else's stuff that maybe wasn't intended for me. So I've got my stuff here. So I'm just going to save this to my desktop. Okay, so the my stuff here, if I right click on it, now if this was encrypted for me to view, I would go decrypt and verify, and then I would click on the decrypt button, and normally it would pop out a valid thing, but it said that it failed. And if I look at the details, it says one unknown recipient, which means I wasn't included in this message, so I can't decrypt it. And if I take a look, I can't read any of this. This has nothing useful for me. So what PGP is really good for is it's good if you want to encrypt data and transmit information in an unsecure environment, but making it secure. Blackboard is a perfect example. Discussion board. Anybody can read anything on the discussion board. If you're placing something in the discussion board, anyone can read it. But if you encrypt the data and then post it on the discussion board, people can read the encrypted content, but they can't decrypt it, so they really won't be able to read the intended information. So hopefully that makes sense. An example, when I did work with the college for production work, we deal with vendors that need student IDs, like to validate student IDs so they can get discounts on software and stuff like that. So one of the programs would run every night and would grab a list of student IDs. Now technically a student ID isn't anything that's sensitive or confidential, but we don't want everyone's student ID just getting leaked out. So what the vendor wanted is they wanted us to upload a text file every night that had an updated list of student IDs. So that way if a student went there, they could type in their ID and they could validate that they were a student at the college. Well, what we ended up doing was FTP is a horrible way of transmitting data, but that's the way they did it. What we did is a workaround is we said, well, we'll allow the data to be FTP'd, but it needs to be encrypted first. So the process would pull all the student IDs, put it into a text file, then we ran PGP, we encrypted it, and then we FTP'd the encrypted content to them. So then the encrypted content was sitting on an FTP site. Then they ran a nightly batch that would grab the encrypted student IDs, then it would decrypt it on their end and then process it into the system. So that was a way that we were able to securely work around passing data in what I would consider to be an unsecure environment. So PGP is one way of doing it, and this is using the same type of technology as when you're using like an HTTPS. They're using a public key transfer. Now, what's different when you're dealing with HTTPS, what they have is they have a trusted authority. So like, for example, on some of my websites, I've got it where it's an HTTPS:// so all the transmissions are secured through an encrypted channel. Now, in order for that to work, I needed to get a certificate from like VeriSign, Thaw. There needed to be a third party involved, and that's what's called the trusted authority. So somebody actually validated and made sure I am who I say I am. I actually had to pick up the phone, answer it when they called, answer a couple security questions, and then of course I had to pay them. And the reason for the payment, well, I've got my own concepts why I had to pay them, but what the real idea is that they have a money trail leading back to me, so that way they can definitely validate that I am who I say I am. So anyways, that's one style of encryption, which is kind of nice. There's another way that I encrypt data, and I've used different tools throughout time. I used to use TrueCrypt. TrueCrypt kind of left the scene, and there's a vacuum there. So I think probably one of the better ways of encrypting data today in a container folder. All right. So for example, if I want to keep my personal information personal and secure, I have a container that I hold all my stuff like taxes in there, any personal records and things that I consider to be sensitive. I put that into a container file and I encrypt that container file. So there's different tools that you can use, and what we're going to do is we're going to disconnect our CD-ROM. And then we're going to connect up to the CD again, and we're going to connect to an ISO image on a data store. And then on the data store, we're going to use something called Descriptor. So Descriptor does something similar to what TrueCrypt used to do, and TrueCrypt basically gave you like a volume or a disk, and you could encrypt that entire volume or disk. I actually really liked the way they handled the encryption, but for whatever reason they weren't getting funding the way that they needed to have funding. So they walked away from the project and said, we're not supporting it anymore. If there's security vulnerabilities, no one will ever know, and you shouldn't use the product. So from that point, initially what I did is I jumped and I used BitLocker. And BitLocker, if you're using Windows 8, Windows 8 will have BitLocker included in it. If you're using Windows 7 that has Ultimate, that will also include BitLocker. So you have to have the right version of Windows to have BitLocker. Currently, we're using Windows 7 Professional, so unfortunately, our flavor doesn't support BitLocker. But BitLocker works the same way that Disk Encryptor works, so they're identical. So if you go to your computer and you right-click and you see that there's an BitLocker menu option, I would probably use that instead of downloading a third-party product. But this is an open source, completely vetted application that has been known and trusted. So what I'm going to do is I'm just going to run this installer. And I'm just going to work my way through the wizard. I'm just going to go next. I'm going to accept the license agreement. I'm going to go next. I'm just going to take the defaults here. I'm going to let it install, and it's going to restart my computer again. So Disk Encryptor basically will encrypt your entire hard drive. Now, I don't want to encrypt my C drive. Now, if I were to encrypt my C drive, it actually would make it more secure. So before booting into Windows, basically I would have to log into the disk decryptor, give it my password, and then it would boot into Windows. So if you remember some of the first labs we did this semester, we ended up like changing administrative passwords or using rainbow tables and getting passwords and cracking passwords. All of that was possible because we had access to the C drive, the hard drive. If we encrypted that C drive, our disk would be secure. So, like for example, if somebody brings me a computer and they can't boot it anymore, but they've got all their family photos on it, the first thing I do is I just jerk the hard drive out of their computer and I plug it in as a secondary hard drive into my computer. And then what I'll do is I'll go to my computer and browse, and then their hard drive will be like my E drive or F drive. I'll browse, I'll just copy all of the images and data off and burn it to a disk and give it back to them. So that's the way I normally do it. So if we were using the disk decryptor, all of that data would be encrypted. So if somebody were to pull my hard drive out, plug it into another computer, they wouldn't be able to get anything off of the disk. So it secures the disk. So a lot of times I think about there's been issues with people having laptops stolen. I know like the IRS and there were some people in the Social Security office that ran into problems where all of a sudden somebody would steal a laptop and then just hundreds of thousands of Social Security numbers were on the laptop and they were there in plain text, so the hacker was able to exploit that and get that information out and upload it to a website. So this will completely prevent that. Now, disk decryptor, I'm not going to encrypt my hard drive. I don't want to encrypt my physical C drive. What I want to do is I want to make a virtual drive. In the virtual drive, I'm just going to stash it somewhere that no one knows, and then from there I'll use that. So for me at home, I've got a certain location that I hold like all my tax information, and I make it a little secretive so that way people don't really know what's going on. So I'm going to click on my Windows key, and I'm going to right click on my computer, and I'm going to go to Manage. So what I want to do is I want to get to the disk management utility. So underneath the storage, there's the disk manager, and this shows me my C drive, all right, which is great. But what I want to do is I want to create a virtual disk. I want to create a disk that is not really a tangible disk. I want to make a virtual one. So underneath my Actions menu, what I'm going to do is I'm going to go to the Create VHD, which is Virtual Hard Drive. So the first thing I'm going to do is pick out a location. If it was me, I would probably put this virtual hard drive somewhere where someone probably wouldn't be able to find it easily. So I'd just stick it like in the Windows directory, in the Windows System 32. There's a lot of stuff in here. So if somebody were really trying to find it, it would become more difficult to find it in the Windows directory. And then I'm just going to call it WinSys. and then I'm just going to save it. So I'm creating a WinSys file in my Windows directory, and I'm just going to give it a file size. For this example, I'm just going to make it 100 megabytes. You want to make sure that the file size is something that you would expect. If I had, a 30 gigabyte file, that would kind of throw up a red flag if I'm trying to be a little bit conspicuous. And I'm going to make it dynamic, so that way it'll grow as I put things in there. It's not going to automatically just take up that 100 meg. So I'm going to say OK. So at this point I've got a virtual disk that's completely unallocated. So what I'm going to do underneath this disk, it's kind of like a little button over here, a placeholder. I'm going to right click on there, and I'm going to initialize the disk. So I'm going to make it master boot record, an MBR, just a normal disk that you would, if it was a physical hard drive, it would be an MBR. So I'm going to say OK. So now I've got a disk, and I'm going to right click on it, and I'm going to create a simple volume. So at this point, this is where I'm going to format it and give it its space and all of that. So I'm just going to go next. And I'm going to give it a drive letter. E is good. E will remind me that it's encrypted, right? So I'm just going to go next. It can be any drive letter, it doesn't matter. I can select the file system type, and I'm just going to give it a volume label. I'm just going to call this data. So I've now got an E drive. So if I were to actually look on my computer here, I can see I've got my C drive, I've got my E drive, and at this point I can create folders and files, and I can put stuff in that E drive. But right now this E drive is just a hidden drive. So if I detached it, somebody would have to know where it is and then attach it. But if they found it, it's got the extension of VHD, so I mean they probably would know to attach it if they found it, and they could see all my data. So for right now I'm leaving the E drive attached and well, but what I want to do is I want to encrypt it. So I'm just going to minimize this for right now. So if I open up my disk crypter and run it, I can see all the hard drives, including my E drive. So if I click on E drive, now I'll be honest, this is hard to see, but it's actually white. If I click down on D, you can see it turns white. It's very subtle, so it's hard to see which drive is encrypted. But down here I can see that it is a hard drive that's connected. So I've got my E drive connected. And what I want to do is I want to encrypt the entire E drive. So my virtual drive is going to be encrypted. So I can select the algorithm. So I want to talk a little bit about different algorithms. When I first became a programmer, I just graduated from school and I thought I was so smart and I had tons of fun and I loved writing code. One of the first places I worked for needed to have some back-end encryption to deal with certain processes. And I kind of wanted to show off a little bit, and I thought I'm going to roll my own encryption algorithm. So I created my own algorithm, and I thought it was kind of creative. It dealt with milliseconds, and it fluctuated, and it had certain replacement characters, and to the best of my knowledge, it's completely flawless. It didn't have any issues. But years later, thinking about what I know today, it really was a bad call. It was a bad call all the way around. First of all, it wasn't a well-vetted algorithm. It was an algorithm, I just made it up. I sat there and I wrote out different stuff and I just made something up. Okay, so the problem with somebody making something up is they may not work there forever, all right? And I don't work there anymore. And it does have a back-end algorithm that I know the internals of. Now, I don't really remember all the internals. It was quite a few years ago. But if I were to have kept that information, I probably could crack that encryption and mess around on their back end system in a way that they didn't want. So that's a huge problem. The other problem is if somebody were to have maybe gotten my notes, or maybe I didn't shred them, maybe I just threw them away, somebody else could have compromised the security, and once the security is compromised, they don't have an option except for rewriting their whole back-end system. So years later, programming for many more years, learning more as I'm going through, I learned that I'm a Microsoft programmer, but all programming languages have certain namespaces that provide pre-built encryption algorithms. So Microsoft's got the security namespace, and they've got tons of Rajul, AES, Twofish, Serpent. They've got tons of different algorithms. So the thing with pre-built algorithms like AES is it's been completely vetted, meaning that cryptologists, people that sit around and think about encryption all day, nitpick over little tiny details of these algorithms and make them extremely good. And they go through competition, so people actually will compete and come up with their process, and they'll compete on speed and accuracy and security. So you always want to use something that is pre-built. So for example, I'm going to use AES. Now if I'm super paranoid, I could use like AES, Serpent, Twofish, all combined. So it'll use one, then it'll do the next one, then it'll do the next one. AES is perfect for what I'm doing. And the wipe mode, it doesn't matter. The wipe mode will format it at a low level, so that way it will not be able to be recovered. So like for example, the DoD is the Department of Defense, and the standard is an 8 wipe. So there's different wipe methods. This is a brand new disk, just created it, just formatted it, so I know there's nothing sensitive on it, so I'm not even going to wipe it. Wiping a disk takes a long time. It'll take many, many hours to wipe a disk. I'm going to go next. So since we're on wiping disks, if I was junking an old computer, I wouldn't just throw it away. I would need to make sure I wiped the disk. Back in the old day, I used to use a sledgehammer. All right, I don't use that anymore. There are services that offer disk shredding that'll shred hard disks. What I do today is actually I use a tool called Drake's Boot Nuke. It's DBAN. It's an open source. You can download. It's a bootable disk, and basically I just pop the disk in, and it takes me through a menu, and it will allow me to basically wipe a disk way beyond the DoD standard. So it'll like overwrite the entire disk with ones, and then I'll go back and overwrite it all with zeros, and go back and overwrite it with random. And so it's a really good way of wiping disks. So if you do want to wipe a disk, Drake's Boot Nuke is a good tool to use. Okay, but we're talking about encryption here, and I am at the point where I'm going to create a password. So with like AES, the weakest part of an encryption should be your key, all right, what your password is. And if you come up with a long, secure password, everything will stay solid. So that's really the important part here, is to use a pre-built, well-vetted encryption algorithm and then generate a really strong passphrase. So I'm just going to come up with a passphrase. So this is a medium one. I'm going to redo this again. So I could go longer and make it more difficult if I wanted to. There's also this concept of a key file. So a key file would be a specific file. So we've got multi-factored authentication, and basically the way that I always think of it is what I know, what I have, and who I am. Those are the 3 factors of authentication. What I know a password. If you know a password, that's a single authentication factor. Meaning if somebody in another country happens to guess my password, my security is then broken. So what I need to have like a physical device, either a fob, something that rotates my password, or maybe an RFID proximity card. That's something I have. So if I need to get into a room, what I've got a proximity card. I walk up to the door, I swipe it, it lets me in. Who I am is basically like a fingerprint, a retina scan, something that identifies me based on some type of attribute I physically have. So those are the different authentication factors. Whenever you can mix and match authentication and have multi-factor authentication, that's always good. So if you need to have some type of a proximity card and know a password, that's good. So if you think about like your bank card or your ATM, you need to physically have the card to swipe, but you also need to have some type of a PIN number to type in. So that's multi-factored. So what they're doing here is they're saying you can give us a password, but you can also select a key file. So maybe it could be a family photo, something that you have. So somebody would really need to do a hardcore job hacking you to get your password and get this special key file. I'm not going to use the key file. One thing with the key file is if you're using like a family photo and that's your key file, and your kid double clicks on it, opens it in Paint, and puts one black pixel somewhere on the image, it's now going to be a different MD5 hash, so the key file will no longer work. It'll be a different key file. So even one pixel difference will completely change that key file. So just a word of warning there. If I were going to use a key file, I'd probably use Waterfall or LilyPad, something that is like a default background. So if the background changes, or I delete it, or it gets corrupted, hopefully I'd be able to Google and find it the same exact image. It would have to be exact. So anyways, that's what a key file is. Just some words of thought. I'm going to go OK. And at this point it is now encrypting my disk. And yay, my disk is encrypted and mounted. So at this point, if I go back into my hard drive, I go into my E drive, everything feels exactly the same. I can right click and I can, create a new text file. And I could put sensitive data in there, maybe all my customers. It could, be anything. So I'm just going to save this. I could drag my tax information and put my tax information in here. So it's just a volume that's encrypted that allows me to contain any sensitive data. So what I can do is if I go back into the disk cryptor and I can unmount it, basically meaning that it's going to remove the encryption. And if I unmount it, it's no longer going to be accessible. So if I go to my computer, I still have that E drive, but if I try going to it, it's going to look like just a hard drive that needs to be formatted. Now if you format it, you're going to lose everything, so that's not what you want to do. So that's one way of protecting stuff. And if you go back into your disk manager, you have the ability to detach the virtual hard drive. So if somebody were to come up to my house and look at my computer, they wouldn't even know a virtual hard drive existed. So for example, next tax season, I'm ready to do my taxes and I want to grab my old data. What I would basically need to do is I would go to my computer and I don't have the encrypted drive. So I need to first mount that drive. So I'm going to right click and I am going to go to my manage and I am going to go to my disk manager. Now I already have a disk, so I don't want to create another one. I'm going to go to my actions menu and I'm going to attach my virtual hard drive and I need to browse to it. So it's in my Windows directory and it's called win sys.virtual hard drive. I'm going to open that. I'm going to say OK. I've got it, but it's still not readable. It's saying, do you want to format it? I'm just going to hit cancel. And then what I'm going to have to do is I'm going to have to go into my disk cryptor. And I'm going to have to select my E drive. And I'm going to mount it. It's going to prompt me for my password. say OK. It mounted the drive. So now I can open it up and I see my sensitive tax information. Okay. So what I'm going to want you to do is if you just open up your E drive here, and if you open up Cleopatra here, at this point, if I see the Cleopatra, and I want you to go to other certificates so I can see that you've imported some people and that you've done this lab. And if you have your E drive, and I'm going to open up my descriptor. Okay, I can see that you have done this lab because you've got students in your Cleopatra. I can see your E drive is mounted, and I can see you've got something in there. So if you grab a screenshot of this, then this will complete this project. And then at the bottom of the document, please write a short paragraph describing the benefits of using these tools on your own system. How would you use these tools in a work environment? So for example, we've used the tools in a work environment. Obviously, I gave the one example with the FTP being able to transfer data, but also like all of our domain controllers, all of our Exchange servers, all of those machines have passwords that are extremely long and complex. They're like 52 randomized digits, and no one knows what they are. But they are all held in a text file in an encrypted volume on a machine with a really long passphrase. So if somebody ever would need to log into one of those systems, they would be able to log into the system, but they'd have to have the super secret password. So all of that data is being held like inside this volume. And for your home use, awesome. I use this all the time. So hopefully you found this lab useful, and I'll talk to you soon.